Okay, so what we're going to talk about with this section is kind of going to be a review of the first two sections to some extent. And then our goal is going to be, which kind of here's where the difference is going to be with this section compared to the other section, is going to be, so this is to graph trig functions by translating them left and right and up and down. Okay, so that's kind of going to be the main point. So you'll see that we will still talk about, when do we vertically stretch and compress trig functions horizontally, which is kind of what we also talked about in sections 1 and 2. But what we're going to do now is we're going to focus on the graphs of, so graphing y equals, so I'm just kind of going to write the general form of sine and cosine, and then we'll talk about each component. Some of the components you already know. So if I say a sine of b times t minus c plus d. So what I want to point out to you is a, b, c, and d we're going to treat as constants, right? They're going to be numbers. Our only variables are t and y. Okay. Now also notice how I'm writing the b with the t minus c in factored form. It's important that you always write this in factored form, because then you could easily see the specific type of transformation we're talking about. So just always remember the t, technically speaking, has to have a 1 in front of it. If it doesn't, then we have to factor that number out, so we make just the t by itself. So just keep that in mind, because that's going to be an important idea here, or an important feature of, or part of what we're going to be doing. So and of course we care about y equals to a cosine of b times t minus c plus d. Okay, so with that said, now we're going to basically talk about each one of each parts of this. So for instance, we're going to say a, which is these guys, and see, we've talked about a already. What is a that we're doing? This, we, in last section, we said this is the amplitude. Which means we can multiply the y values of the graph of our trig functions by a. Okay, so this a is literally, so that's nothing new, we've talked about it before. A just means these a's are us multiplying the y values of our trig function by a. Okay, now what's b? If you remember, we also talked about b. B is tied down to the period, right? So remember, this helps find the period. Also, as we're saying it helps find the period, we know that what we notice is that if b is something other than 1, which would mean that if the period is not 2 pi, so we know that if the period for our trig functions for sine and cosine is not 2 pi, and we know how to find the period, that means we need to adjust, we can adjust the key values, which the key values we're talking about, those are our x values, or the t values as we call them, by multiplying 1 over b, so it's kind of like the reciprocal of whatever b is. So we're going to be multiplying 1 over b to the x values of the graph. Of sine or cosine, depending on which function we're graphing, right? So kind of that's what we're doing. So a and b, nothing new, because if you remember, we did that last section. And we will start from the most basic trig function, like sine or cosine, and then we'll create what we need to create. Now, let's talk about the c. Now, notice how the c is tied down to, or is paired with my t value, or the x value as we call them. So the c is going to indicate how much we shift our graph right or left. So this is our horizontal shift. So we're going to say c represents the horizontal shift. So that means, which means we move the graph C units to the right if C is greater than 0, and C units to the left if C is less than 0. Okay, so what we're basically saying in parentheses, all you're really doing is what our key values are. We're just going to be adding C to all key values, right? That's kind of what we're doing here. So if C is a negative number, when we're adding, we're technically speaking, we're subtracting. Okay, so so for instance, if I were to give you an example, we could say, look, y equals the sine of t minus 3. See, since it's t minus 3, now look, the minus is fine because it kind of fits that description. So if it's minus, that means c itself must have been positive, right? So it's kind of like the way we think of it is what you see, always think in terms of the opposite. So this shifts sine of t 3 units to the right. Whereas if we have something like this, if we have something like, for instance, y equals to sine of t plus 1, notice how since this is plus 1, the c must have been negative 1 to make this negative into a positive, right? So c must have been a negative 1. That's why it's plus 1 now. So this means what? Shift sine of t 1 unit left. And more importantly, the ones that are most the ones that we have to be most cautious about are the ones that look like this, sine of 2t plus 4. See, and this is the point I'm trying to make, and if you look at this, you might say, hey, this is saying shifted 4 units to the left, but that's not the case, because look at the t, it doesn't have a 1 in front of it. So I have to write this in factored form, which means I would have to factor out the 2, which then looks like this. And then when you write it in factored form, then you could easily see that, hey, this is actually a shift of t unit, or 2 units to the left. So this is shift 2 units left. So just keep that in mind, okay? So that's important. Now, let's go on to the last part, and then we'll do some examples where we'll perform all these transformations, and you'll see how it works, which is this D, okay? So I think by now you could probably guess what that D is. see if the C is moving things left and right, then the D, we're adding it to this whole thing, which means that's how we're moving things up and down. So let's talk about D here. So for the D, we're going to say this represents the vertical shift. Okay, now for this one, it's not like the opposite of left and right. We just take it for face value. So what we'll do is we move the graph up, the graph D units up if D is greater than 0, and D units down if D is less than 0. Okay, so the good news here is, technically speaking, we should know that, hey, by looking at your function, you should know what we should perform, okay, or what transformations are at play. Okay, so with that said, before we do some examples, there's a couple of comments I want to make. So the notes that I want to make for you guys is we will always start with the graph of sine of t or cosine of t. So depending on which one it is we're working with, right? So it might be sine or cosine depending on which one. First, so the most basic one. So we all know, hopefully by now, we can graph the sine of the graph of sine and cosine without any problems. Then we will, so we'll do that first, then we'll perform each transformation one at a time. And I highly recommend that you do that on the test, and I will ask you to make sure to graph this by transformation. So I highly recommend that you do this one at a time, only because if there's any small mistakes you make, I'm more likely to catch the minor mistakes, and you'll get most of your points on that question right. Okay, so the ideal order, now notice how I'm calling this ideal order, is because there is no official way to follow it, but the ideal order to apply the transformations are, so these are the ideal order. Now this is what I follow. You don't have to do it this way, but I think this is probably the best way to approach this so we don't make any mistakes. So I first always multiply y values which is determined by a. That's what I go after. Then after I take care of the amplitude, then I multiply the x values, which that's determined by b, which is determined by b. And then what I do is I subtract y values by d, and then 4 I subtract x values by whatever c is. So, and in all honesty, 3 and 4, that doesn't matter. You could do them in any order, right? If you want to move left and right first, then up and down, or you want to move up and down first, then left and right, that's up to you. But as far as the multiplication stuff goes, I would do those first, okay? So same thing, I guess, for the steps 1 and 2. This order doesn't matter, but make sure to do the multiplication first, then the addition and subtraction next. That'll help minimize your error. And hopefully you won't make any errors by following those steps. So let's look at some examples here. So we're going to say, for example, 1, graph y equals to 3 sine of 1/2 t plus 4. So by looking at this, see right away, I know this 3 is saying what? We multiply all of our y values by 3. This 1/2 in front of the t, what is that saying? That's saying, look, we're going to multiply all of our x values, or the t values, by the reciprocal of 1/2, which is 2. So I'm multiplying all my x values by 2. This plus 4 sits on the outside. This is saying I'm just adding 4 to my y values, which means I'm shifting it up. So I'm going to start off, and I'm going to use transformations. So I'm going to start off with sine of t, which that's the most basic one. And if you remember, the key values are 0, pi over 2, pi, 3 pi over 2, 2 pi. So we know at 0 it's 0, at pi over 2 it's 1, at pi it's 0, 3 pi over 2 it's -1, 2 pi is 0. So I'm only graphing one period here. Okay, so that's one period of sine. So then I'm going to take care of, let's say, the 3. So then I want 3 sine of t. So how does the graph change from here to here? This is saying just multiply all your y values by 3. So my x values aren't going to change. However, my y value, see over here, my y value is 0. So if I multiply it by 3, 3 times 0 is still 0. At pi over 2, my y value is 1. 1 times 3 is 3. At pi it's 0. 0 times 3 is still 0. 3 pi over 2 is -1. -1 times 3 is -3. At 2 pi it's 0. So my new graph looks like this, which notice how it's been stretched vertically compared to that. Okay, so let's move on to the 1/2. So the 3 sine, notice how I'm taking this step by step. It might be more time consuming, but I'm making sure that I don't make any mistakes here. So then the next one is 3 sine of 1/2 t. So what is this saying? Multiply all your t values or your x values by the reciprocal of 1/2, which means multiply them by 2. So if I look at the original graph, my x value here was 0. 0 times 2 is still 2. The next one is what? It's pi over 2. Pi over 2 times 2 is pi. And at pi over 2, my y value was 3. So now at pi, my y value will be 3. At pi, my y value is 0, but now I'm multiplying pi. Notice how I'm only multiplying the t values now, and the y values don't change. So at pi, it was 0, but now when I double it, at 2 pi, it'll be 0. 3 pi over 2, when I double that, it becomes 3 pi, and at 3 pi over 2 is -3. Now at 3 pi, it'll be -3. I'm running out of space here. And then 2 pi, it's at 0, so if I double that, I get 4 pi, it's 0. So then I get this graph. So notice what happened from here to here. It looked like it got stretched horizontally, okay? And then lastly, this plus 4, which would do the last thing, which is the 3 sine of 1/2 t plus 4. What is this saying? Just add 4 to all your y values, and then that'll basically wrap this up. So I'm running out of space, so I'm going to condense this. So this is pi, 2 pi, 3 pi, 4 pi. I'm sorry, the spacing doesn't match that, but I'm just out of space. So then what am I doing? I'm adding 4 to everything. So if this was 0, now it's at 4. This was at 3. Now if I add 4, it'll be at 7. This is pretty awful. I'm running out of space here. At 2 pi, I was 0. If I added 4, it puts me at 4. At 3 pi, I was at -3. But if I add 4 now, it puts me at 1. And at 4 pi, it's 0. So notice how this graph got shifted upwards. And here's my final graph that I was talking about. So notice how Understandably so that these transformations could be time consuming, but if you take it step by step, you're not going to run into any issues. Okay, so let's look at a second example. So for example 2, we say graph y equals to -2 cosine of t minus pi over 6. Okay. So what we're going to basically do is now we're going to say, okay, start off with cosine of t. So if I start off with cosine of t, we have 0, pi over 2, pi, 3 pi over 2, 2 pi. And we know cosine of 0 is 1, cosine of pi over 2 is 0, cosine of pi is -1, 3 pi over 2 is 0, 2 pi is 1. So that's one period. So let's take care of the -2. So the -2 cosine of t, what's that saying? Multiply all your y values by -2. So at 0 it was 1, but now it'll be -2. At pi over 2 it was 0, and multiply 0 by -2, you still get 0. At pi it was -1, you multiply by -2, you get 2. 3 pi over 2, 0, 2 pi, -2. So one period looks like that. So it kind of got stretched and flipped, right? Because of the negative, and the 2 stretched it out, okay? So now the last thing we need to do is the t minus pi over 6. Now the t minus pi, what is this pi over 6 saying? Shift everything pi over 6 to the right. So in other words, what am I doing here? I'm grabbing all of these t values and I'm just adding pi over 6 to them. So it's going to be just moving to the right a distance of pi over 6. So if I have -2 cosine of t minus pi over 6, what happens here? At 0 it was -2, but if I add pi over 6, that puts me at pi over 6. Now it'll be -2. At pi over 2 it was 0, but if I add pi over 6 to pi over 2, what do I get? Pi over 2 plus pi over 6. That becomes what? 3 pi over 6, 4 pi over 6, which is 2 pi over 3. Right, so I'm just literally adding pi over 6 to these, which then that puts us at 0 now. At 3 pi over 2, it's 2, but when I add pi over 6 to this, what do I get? I get 6 pi over, or 9 pi over 6, plus pi over 6 is 10 pi over 6, which becomes 5 pi over 3. And then for the pi, if I grab pi and I add pi over 6 to that, that'll be 7 pi over 6. And that'll leave me at 0. And then at 2 pi, if I add pi over 6, oops, I have these mixed up. Sorry, this is pi, this is 3 pi over 2. My ordering was mixed up. So these two should switch. All right, so this should be 7 pi over 6, 5 pi over 3. My apologies. So I just swapped them accidentally. And then to 2 pi, if I add pi over 6, it'll be 13 pi over 6, which puts us there. And then if I graph this, it looks like that. So it just literally got shifted pi over 6 to the right. Okay. So let's do one where we'll see a bunch of transformations. So the next one is example 3, which is graph y equals 5 over 4 sine of 2t plus pi over 2 minus 1. So there's a lot going on here, right? There's how many transformations? 1, 2, 3, 4 transformations. Now remember, since the t isn't 1, it has a 2 in front of it. We're going to rewrite this as y equals to 5 over 4 sine of 2 times t plus pi over 4, right? So if I factor out a 2, the pi over 2 becomes a pi over 4. Okay, so with that said, now we have, we know that this is a vertical transformation. I have to multiply my y's by 5/4. So let's start off with sine of t. which is 0, pi over 2, pi, 3 pi over 2, 2 pi. So at 0 it's 0, pi over 2 it's 1, pi it's 0, 3 pi over 2 is negative 1, 2 pi it's 0. So we have that. And then we take 5 over 4 sine of t, which that just means multiply your y values by 5 over 4, so that's going to be 5 over 4, negative 5 over 4, so it'll be 0, pi over 2 will be 5 over 4, pi will be 0, 3 pi over 2 will be negative 5 over 4, 2 pi will be 0. So there's one period of that. Okay, so next let's take care of that 2. So this is saying what? Multiply your t values by a half. So then we have 5 over 4 sine of 2t. And that is, we know that the y values aren't going to change, only the x values. So at 0, it'll still be 0, because 0 times 1/2 is 0. Pi over 2 times 1/2 will become pi over 4. And at pi over 4, it'll be 5 over 4. Notice how, once again, my y values don't change when I'm multiplying these by 1/2. So at pi, it's 0. So at pi over 2, it'll be 0. 3 pi over 2 is negative 1. So at 3 pi over 4, it'll be negative 5 over 4. And at 2 pi, it's 0, which means at pi, it'll be 0. So that takes care of this transformation. Okay, and then the next one is what? 5 over 4 sine of 2t minus 1. So I'm choosing to do that, which is saying subtract, move things down 1. So it's literally this graph, same graph, just everything moved down 1. So pi over 4, pi over 2, 3 pi over 4, pi. So if I move everything down 1, so at 0, it'll be negative 1. At pi over 4, instead of 5 over 4, now it'll be 1/4. So it'll be, that's 1/4. Pi over 2, it'll be negative 1. At 3 pi over 4, it's negative 5/4, which now will be negative 9/4. And then at pi, it'll be 0. Okay, so the last thing I need to do is what? This, if I come back up here and look at this, the plus pi over 4, that means move it to the left pi over 4 units. So if I move things to the left pi over 4, what do I get? I have, well, if it's 0, now it'll be where? At negative pi over 4, it'll be negative 1. Right? And then if this is pi over 4, if I subtract pi over 4, now at 0, it'll be 1/4. At pi over 2, if I subtract pi over 4, it'll put me there, which at pi over 4, it'll be negative 1. 3 pi over 4, if I subtract pi over 4 from it, it'll be pi over 2, and that'll be at negative 9/4. And then at pi, if I subtract pi over 4, I get 3 pi over 4, and there it'll be negative 1. So it's basically this graph. And if you look at this, this is that guy just shifted pi over 4 to the left. So I literally took all these t values and subtracted pi over 4 from them. Okay, so now let's move on to the rest of the graphs, tangent, cotangent, or actually there's one more example and then we'll move to the other ones. So this one is just more through observation. So we could say identify the amplitude or period horizontal shift and vertical shift of y equals to 2.5 sine of pi over 4t plus 3 pi over 4 plus 6. Okay, so by looking at this, I'm going to say, okay, first of all, I want to write this in factored form, so I'm going to rewrite this as 2.5 sine, factor out of pi over 4, because remember the t has something other than a 1 in front of it, which this will be what, t plus 3 plus 6. Okay, so now I could answer the question, what's the amplitude? Amplitude is 2.5. Okay, what's the period? The period is what? 2 pi over b, which b is pi over 4. So it'll be 2 pi over 4. And then anytime we divide by a fraction, we say 2 pi times the reciprocal of that, which the pi's cancel out, and I get 2 times 4, which is 8. That's the period. And then what else? The horizontal, so let's just call it hs for the horizontal shift. That's left and right, which the plus 3 is saying we're moving 3 to the left. And then lastly, the vertical shift, so we can call it Vs, it's what? The plus 6, which means 6 units up. Okay, so notice how before, like when you look at a graph, you can just by looking at it, you know exactly what's going to happen. Okay, so now let's move on to the other trig functions, which I'm not going to emphasize too much on these because they're very, very identical to what we've been doing with the sine and cosine. So we will now, so I'll do a couple of examples. So we will now focus on graphs of the form y equals to a cosecant of b times t minus c plus d, y equals to secant, or a secant of b times t minus c plus d, y equals a tangent of b times t minus c plus d, and y equals a cotangent of b times t minus c plus d. Okay, so and the a, b, c, and d still do the same thing. So a couple of comments I want to make before we do these examples. So remember that we will use sine and cosine to produce the graphs, of cosecant of t and secant of t, right? Remember, that's going to help that out. Then we can then use the transformations as before. So we're going to notice that the transformations that we did for sine and cosine are the same. So the roles of A, B, C, and D are the same as before. So it's not like we're learning anything new. That's the good news, right? If I know how to graph one period of all the other trig functions, then I could easily apply the transformation. So let's look at an example. So for example 5, I could say graph y equals to 3, or maybe I should do this on the back side so we have more room. So I could say, for example 5, graph y equals to 2 secant of pi over 3t minus pi over 2 minus 3. Okay, pi over 3t, sorry, minus pi over 3 minus 3, which if I rewrite this, it'll be 2 secant of, factor out the pi over 3, which leaves me with what? T minus 1 minus 3. Okay, so if I do this, then let's start off with the graph of secant. Now remember, secant is the reciprocal of cosine. So if I start off with, if I use the graph of cosine, I could easily force out the graph of secant. So this is secant of t. But if you remember, one period of cosine looked like that. And if you remember, when cosine is 0, secant has vertical asymptotes. And when cosine hits a maximum, secant shares it and goes up. When cosine hits a minimum, secant shares it, goes down. Okay, so all I care about are the solid graphs and the vertical asymptotes, of course. So let's start off with 2. So what would 2 secant of t be? That's just saying grab all your y values and multiply them by 2. So we have 0, pi over 2 pi, 3 pi over 2, 2 pi. So at 0, it'll be 2 now. Pi over 2, it's still a vertical asymptote, right? Vertical asymptotes never all of a sudden become non-vertical asymptotes. Negative 2, at pi it's negative 1, so it becomes negative 2. 3 pi over 2, we have a vertical asymptote at 2 pi or 2. So now this goes up, down, up. Okay, so what's next? Let's talk about the pi over 3. So if I graph it here, so it'll be 2 secant of pi over 3 t. What would this one be? This was saying just multiply all your values by 3 over pi, right? So if this is, for instance, 0, it'll still stay 0. This is pi over 2. If I multiply it by 3 over pi, it just becomes 3 halves. We have a vertical asymptote at 3 halves. And then at pi, if I multiply it by 3 over pi, it just becomes 3. So at 3, it's negative 1. 3 pi over 2, if I multiply 3 pi over 2 by 3 over pi, that just becomes 9 over 2. We have a vertical asymptote. 2 pi, if I multiply that by 3 over pi, that becomes 6. And that's 2. Okay, so what's next? We took care of that, so let's do the, this time I'm just going to do the secant of pi over 3 t minus 1. So as you could see, I'm just trying to show you that it doesn't matter if you move right and left first, then up and down. But if I move right and left first, what is this saying? Move everything 1 unit to the right. So at 0, now it'll be what? 1. And 1, it'll be 2. At 3 over 2, if I add 1 to that, that becomes 5 over 2. That's my vertical asymptote. And then at 3, if I add 1 to that, that becomes 4. It's negative. And then at 9 over 2, if I add 1 to that, it'll become 11 over 2. We have a vertical asymptote. And then at 6, if I add 1 to that, that becomes 7, which then becomes 2. So this goes up, down, up. Okay, and lastly, this minus 3, which I'm gonna just, let me just graph it on this same graph just because I'm running out of space and we have one more example. So for this one, the minus 3, so if I put the minus 3 here, what does that mean? Just move everything, all your y values, and subtract them by 3. So if I'm up here, if I subtract 3, it'll put me down there and it'll still open upwards. Vertical asymptotes never change, you just leave it as is. This point that opens downward, I'm going to subtract 3. So since this is negative 2, if I subtract 3, it puts me down there. Hopefully you're not getting confused by this. All I'm doing is just grabbing the graph on top and subtracting 3 from it, from all the y values. So the bottom one are the effects of me subtracting 3 from the upper ones. Okay, so that's my final graph. So once again, if you do this step by step, it's to your advantage. So the last example I want to do before I end this notes is graph y equals to 3 tangent of 1/2 t plus 1. Okay, so once again, by looking at this, I know that I'm going to multiply my y values by 3, my x values by 2, and then my y values, I'm going to add 1 to them. So you might want to pause this video and do this on your own, and then press play. But if I start off with tangent of t, what do we have? We start with negative pi over 2, vertical asymptote. Negative pi over 4 has a y value of negative 1. 0 at 0. Pi over 4 is 1. And pi over 2 is another vertical asymptote, which does that. Okay? So then, 1 period looks like that. Okay? So then, what do we have here? So then, if we look at this, we have then the 3 tangent of t, which this is saying just multiply all your y values by 3, which notice how negative pi over 2 vertical asymptote, negative pi over 4, we're at negative 1 here, but that means if I multiply by negative 3, that'll put me there. 0, it's still 0. At pi over 4, it'll be 3. And then at pi over 2, it'll be a vertical asymptote. Okay, and then next, we take care of the 1/2. So this becomes 3 tangent of 1/2 t. This is saying multiply all your t values by 2. And once again, I'm running out of space, so I'm going to probably put 2 graphs in one. Or maybe I could move up there and do it, no worries. So at negative pi over 2, if I multiply it by 2, what does that become? Negative pi. So my vertical asymptote is now at negative pi. If I grab negative pi over 4 and multiply it by 2, I get negative pi over 2. So now at negative pi over 2, my y value is negative 3. 0 multiplied by 2 is still 0. Pi over 4 multiplied by 2 is pi over 2, which that'll be 3. And then pi over 2 multiplied by 2 is pi, which that gives me a vertical asymptote. And there's 1 period of my tangent curve. And then lastly, this plus 1 is saying what? And I'm just going to put on the same graph. It's just saying move this up 1 unit. So if I do the plus 1, this point moves up 1, this point moves up 1. So it's kind of like doing the same thing here. So this final graph here, that's the last one we care for, right? Because we're just adding all the y values, we're moving it up 1. So this takes care of this section. Hopefully you saw a lot of it was review from the previous sections, except what's new is we're moving things left, right, and up and down. Okay, as always, if you have any questions, don't hesitate to email me or come to my office hours, and I'll be more than happy to work with you on this.